Today's purpose is to tell a story how the baby become a data scientist. Hopefully that is entertaining. I never dare to say education. So what it takes to be a good data scientist? This is my understanding. So we all know that it requires good domain knowledge and coding skills and math stats. But in my opinion and experience, it actually may be more important than to be able to ask the right question and to tell a good story. So today is to check if I can tell a good story. So please be supportive. So a lot of questions that got a very common question to be asked that is necessary to be very good with math to be a data scientist. Actually, it's easier there. So personally, I'm pretty good at numerical problems, but I'm very bad at algebra. So I would say that numerical estimation is good enough. You don't have to be a genius in proving theorems. Guesstimate is always my strength. I had trouble coming up with precise answers to questions. In my opinion, that when facing with very noisy problems, having good intuition actually is very helpful. Back to the university days, I was an engineering major, and I think that this is also commonly shared among many people that the engineering major actually make really good data scientists. So you don't have to be a stats or computer science major. College days were many years ago, but if you ask me what I learned from my college days, I think the only two subjects that I learned that I consider useful after college were linear algebra and programming. So linear algebra is a very important field that I feel that's something that I still use every day. But other things such as social studies or world history, I cannot say that useful. But I did not become data scientist just after college graduation. The reason being that a data scientist as a profession was a very recent invention. So, if my memory serves me, I think even 7-8 years ago, data scientist wasn't a job description. So people didn't call themselves data scientists, and it wasn't popular. So when I graduated college, I actually right around the well-paid time. So there was not a lot of data analytics job. So I ended up being a programmer, like many of my engineering classmates. So and just by chance that it was in insurance. So I think that actually quite fortunate for me, because the insurance industry actually has, in my opinion, the best data to practice data science on, for the following reasons. Insurance data, especially in the property casualty insurance, is very noisy. So very few people have claims, but if you have an accident, that can cost you a lot of money. It has also a high variety of data, and then the data size is just right. It's neither too small to model on or too big to be very hard to process. So I think that's in the insurance industry, I actually got to my first introduction to data itself. So what did I learn when I was working in the IT department of the insurance company? So first of all, let's be honest, it's not how to program. I feel that my coding skills probably became worse while working in the IT department. But I was very interested in learning the business domain. So I think as a data scientist, it's actually very important to understand the particular domain you work in. And I think going forward with more and more automated machine learning tools, is actually the majority of the value of data scientists come from the understanding of that particular business domain, not how you use tools. So another important lesson was that it's actually very crucial to speak the right language, and terminology is very important. I work in several different companies, and most companies have their own set of acronyms, short names for different things. And to get those acronyms right is absolute requirement in communication. And the sad benefit is that I also understood how IT people talk and think. How when I was in IT, whenever people ask me how long does it take get done. I always think about how long it takes to really get it done, and then multiply by 3. So that's very useful skill in your IT. And once you come out of IT and on the other side of the table, and I realize that's what they do, and it's very helpful. So what do you do when you get bored with your job? So I worked in IT for 7 to 8 years. It's actually very interesting and fascinating job. And I have to say that I think that today's IT job arguably is actually much more interesting than the job I was doing maybe 10 years ago. I don't know how many of you are in IT, but for a while I was working with Visual Basic .NET kind of stuff. I wouldn't say those are really technology that make people very excited. But today I think there's a much richer ecosystem out there, especially with open source movement. There's really actually that makes that IT job actually much more interesting. Still, I found that eventually I was not fully satisfied by doing IT job. Mostly for the reason that I spent many years building systems that store numbers, more or less. So many systems, if you think about it, at the very bottom, that is basically enable users to put in numbers and somehow store them. But eventually, I developed curiosity about how to decipher those numbers, what those numbers mean, and how do you get the business value out of them. So that's why I wanted to switch job. From a personal connection perspective, I happen to be married to an actuary. So I think actuaries were actually data scientists way before data scientists become a term. They have been doing that for many decades. So from that, I got exposure to what people do in data analysis. So it took me quite a few years to switch from an IT profession to a data scientist role. In retrospect, I would think that, oh, I was so good at this, people just let me, right? So unfortunately, that's not how the world works. But being naive as I was when I was trying to do the switch, I tried actually several times without any success to convince people that although I have not done any data analysis as a real job up to that point in my life, that I would be really good at it. And based on data collected by me personally, that argument does not work. So the recommendation is I would advise against such attempt. So the only way, in my opinion, to convince others that you can do something and can do something well is to demonstrate that you have done that. So in today's world, it's actually much easier because one, there is a Kaggle tool. There are lots of data science training programs. All provide really excellent opportunities to work on real-world problems. So it took me a little longer time when I switched because there was no such advantage. So here comes in the importance of telling a story. So when we describe what we do and how to tackle a data science problem, it's most times I would say that the most important factor is to describe how you approach a problem, how you think about it, how we decompose a problem from a monolithic question into, say, for example, how do I improve the profit of a particular business unit into many smaller problems that we can tackle as a technical challenge. I think that skill is probably the most important in working as a data scientist in the real world. So there again is the ability to tell the stories. Another one is that it's really helpful to have the right mentor and a sponsor in a career. I think you should basically go out and network and go to meetups and go to a conference like this. And in meeting with more people, not only we can get knowledge of more opportunities, but also we can learn lessons from others. As a tutor, I almost became an actuary. It's quite interesting a few years. So the reason I wanted to become an actuary was that at that time, that seemed to be the most common data scientist. Again, that was 7 or 8 years ago, before the data science became popular. I actually took quite a few exams, but I didn't finish before because by the time I finished the 6th or 7th exam, actually data science become such a popular topic that I don't need to do that anymore. So I become an actual data scientist. So I eventually become data scientist, but if you look at what I do as a data scientist, work with IT developer. So when I was working in IT, this is what I do. So I sit on my chair. I think that picture somewhat looks like me. And, this way. And look at staring at my screen and with a smile on my face, hopefully. And then after I become a data scientist, I'm the right side picture. I sit there, stand on chair, look at my screen. The only difference is actually what's on the screen. So if you zoom the picture in a lot, you will see that on the left hand screen is actually C++ code, on the right hand screen is ROC curve. But it's actually pretty hard to see there. So it's actually, that's interesting. It actually took me a shorter time to become an expert data scientist from being a data scientist compared to a change from IT to become a data scientist. So I think this is following the same philosophy about, the first $1 million, the hardest million to make, and after that it's easier. So Kaggle actually played a very important role in that because that's how I demonstrated technical expertise. However, another very important thing to consider is it's actually very hard to change other people's opinion about you once they know you. So at the first job I became a data scientist, I was always known as the IT guy who became a data scientist. It's only changed slightly. But then 2 jobs switched over. I'm known as an expert data scientist. So the lesson learned there, I think, is it's very hard to change other people's opinion, especially if their opinion is fixed on you. But it's not that hard to change other people. So you can always find a new colleague. So what I learned from being a practitioner, so first of all, I think practitioner is really a funny word. I think that's because we who do not do research really want to find a nice name for ourselves, as a counterpart researcher. So instead of researcher, we call us a practitioner. The most important question, this is what I learned at AIG, is that asking the right question is far more important than getting the perfect answer. So in data science, if you find the right problem to solve, probably with some one-way analysis or logistic regression, you can probably get 80%, 90% answer already. And in most of the cases, that's more than good enough for first round answer. You certainly want to have phase 1, phase 2, phase 3 to refine. But certainly don't spend too much time trying to get the perfect answer. Try to get the right question first. The right question can be asked in many different ways, but I think in the narrow domain of predictive analytics, I think the very good way of asking the question is what can we do differently if we have a prediction of a particular number. If we do not have a really crisp answer to this question, we shouldn't start a project. So that's how I become a data scientist and what I learned in the process. So I want to ask a question, so that I know that many of you came here to, more or less for the title that how I became a #1 hacker. Do you want to see the secret sauce? Show of hands if you want to see that, I can show you. Only a few people want to see it, but I show you anyway, so let me try. I have another slide that I used to talk about more Kaggle focused. So I think it's just to be fair to the title, I want to forgive me. All right, so it's very important that I share my secret sauce because the one thing that I want you to be convinced of that there has to be no mysterious secret sauce. So it's, if you distill at the highest level, that it's a combination of luck and effort. So luck actually is very important. So given the importance of luck, that never get discouraged, because you have difficulty working on a particular problem, or if you prescribe Kaggle for the first 3 competition, you don't do well. But that's nothing. I have been, I had a streak of like 10 competitions I do terribly, but eventually you will get better. So the second part is the discipline. So if you have to have a proper way of validating your model to build good models. If there's no way for you to tell the model is good or bad, there's no way to build good models. Beyond that, there is the domain knowledge and the feature engineering. Most of the meaningful feature engineering are driven by domain knowledge. So whenever we deal with a data science problem, always study up the literature, read magazines, talk to your business partners, make sure that you understand how the process actually works, that generates the data. Then that's the best way of getting the right feature engineering. All the other things are more or less pure technicality. So I want to share this slide so that if you want to say I'm a takeaway, so how to become a #1 Kaggle, at least that's my personal secret sauce. Hopefully that is helpful. Given the short time frame, I want to leave a few minutes for questions so that I will move on. So, yes?
You have done a lot of computations. So
yeah.
In feature engineering, it's the result of domain expert. You have to be expert in many domains. How do you do that? Are you better in some domains than others?
Yes, the question is, there are so many domains, how can you become a domain expert in everything? And am I a person who has like some domain that's better? Yes, absolutely. So I can feel that I'm better at a domain that are closer to what I do as a business. So it's more like a business related question. I feel that I actually have an advantage. Relative to a science-based competition, such as the Higgs boson competition, I can feel I struggle because I tried to read those particle physics papers. I didn't try, and then I cannot understand them. But on the other hand, you do not have to be a particle physicist to work on those problems. And many other domains actually much easier to get into. For example, there are a lot of like Wikipedia sponsored high school competitions. Actually, it's not that hard to get into some tribal industry website to see what they actually think and go to the Wikipedia website and see how they present their information. Another question? Go ahead.
So you said that it is good to find mentors and sponsors. Can you give some tips of how you would go about doing that?
Oh, okay. The question is, I mentioned it's very important to find mentors and sponsors, and how do I did that? That's a very interesting question. So this is my absolute honest answer. I keep trying until I find one. So it's a pure chance. I think some people are naturally born charming, and you can probably charm out 3 people. But me, I think I struggle quite a bit. I think I can only charm out 20. But if you meet like 100, I'm sure you can charm some. Any other question? Okay, go ahead.
How do you find what's the relationship between your competition with your team? Does it help each other, or?
The question is, what's the relationship between my competition experience and my day-to-day work? It helps a lot, but not in a direct way. So I have to be honest that I've never built a real-world model the way that I built a computation model. And I don't think that any company has implemented a top-level model out of computation directly because they are impractically complicated. But it helps me to realize that how easy is it to overfit a problem. And that is even a competition that can be really easy, and that teaches us discipline. And there are also other ways that it helps us, such as it helps us to broaden our knowledge. So it forces us to recognize, it forces at least me to recognize that there are so many things that I do not know. I think we are all human beings. It's easy to convince ourselves that, oh, I know a lot of things already, but when I go there, I compete with someone, they beat me easily, and that's certainly put me in my place. And that's on the more fluffy side, it certainly have a reputation side, so it helps professionally as well. All right, good. The question is on competition, how much time I spend on feature engineering versus supervising. I usually spend 2/3 of time doing feature engineering and 1/3 struggling with my body code.
How do you know that you are asking the right question? maybe it is based on experience, but
Yeah, the question is, how do I know that I'm asking the right question? I can only give you the example when you are working in a corporation in a business. When the person in the room who is paying for everybody's salary, business sponsor, who has absolutely no knowledge about data science, understanding the question, you ask the right one.
Do you use the same validation framework between competitions or similar?
I use it, the question is, do I use a similar validation framework across different competitions? I always use the one exactly the same as the one used by the competition sponsor. So you have to get it exactly right. Actually, they have slight differences between different competitions.
Thank you, Owen.
All right, thank you very much.